In this next unit, we're going to be looking at data representation, and in this presentation, we're going to be looking at the number systems that computer systems use. We want to know the difference between analog and digital signals. We want to know and be able to explain to other people why we need to turn data into binary format for it to be processed by a computer. And then finally, we want to be able to convert numbers between their denary and binary forms. And if you're not sure what that means, just listen on. So, analog devices. If you take a lot of things in the physical world, like for example sound, we have an analog signal. So an analog device or an analog signal works, has a high value, so like the top of the wave here, and a low value, a minimum value, so maximum and a minimum. And you'll notice there's a line, continuous line going from the low point to the high point, and that means every single value in between low and high is represented somewhere in this wave. And if you were to connect a thing called an oscilloscope up to a microphone and were to speak into the microphone, you'd see something like this. You'd see a continuous line and kind of high and low values and all the states in between. That's an analog signal. With digital signal, we have basically two states, low and high, on and off. So you notice on this wave here, when it's not at low, and it goes straight to high. It doesn't kind of go through a series of intermediate states. It just goes straight from the low value up to the high value. And that's what a digital signal looks like. Now, you've got some analogies here of analog versus digital systems. So an analog system might be, say, a dimmer switch on a light. You can turn the light off, you can turn it on, fully on, or you can have it any level in between. With a kind of conventional switch though, it's a bit like a digital system in the sense that the light is either on or off. If we take temperature, a temperature sensor will tell you what the temperature is, and it can tell you the temperature in how many degrees Celsius or Kelvin you've got, any value from absolute zero right up to the maximum that you can measure. Whereas a thermostat, the kind of thing that's connected to your heating system at home. With those thermostats, the way they work is you set a temperature. When the temperature goes above that amount, the thermostat clicks the system off. And when it goes below that amount, it turns the system back on. So it's either on or off. With a vinyl record, you have a continuous sound coming out of the record, and it can represent anything right from complete silence up to the highest sound that you can hear. Whereas on a CD, what we actually have is a series of pulses of sound, individual beeps. And all these individual beeps are the same duration. So it's there's basically two states. And then finally, we've got pressure sensors. So if you've got a pressure sensor in like a chemical experiment or a chemical plant, that will measure the pressure. So for example, it might tell you that this reaction vessel is at so many megapascals of pressure. Whereas if you've got a pressure pad, the way they work, you might use one of these on a burglar alarm, for example. So the idea is when someone treads on it, they activate the signal, but when no one's treading on it, the signal system is not activated. So this is kind of more like a digital thing. Now, modern computer systems are digital machines, and that means anything, if you want to feed a signal into it, like for example a sound, or say an image, you have to convert it from analog form, which is what the physical world's like, into digital format, which is what the computer system needs to works with. And the reason for this is because computers are made of these things here called logic gates. And a logic gate is an electronic circuit in which electricity has two states, on and off. Now, if we want to represent that with numbers, the problem we've got is our number system. So the number system you're used to using is called denary, which means base 10, and it uses 10 digits from 0 up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's 10 digits, and you know some call them digits, not numbers. A digit, of course, we use 10 digits because you've got 10 fingers, thumbs, and therefore when you're starting off with, you can count the things on the end of your hands, and that allows you to count up to 10. And in Latin, the word digit means finger. That's why we use it. But the problem with that system is we can't represent that on a computer because computers can only represent two things. So we can't represent 10. So a computer uses the binary number system. Because digital devices only have two states on and off. We need a number system with 2 digits, and that system is the binary system, which uses 2 digits. They are 0 and 1. And what this means is inside the computer we have to use numbers which are binary. In other words, they only contain those 2 digits, 0 and 1. And you might think, well, that's a bit, how on earth do you do that? Well, this is what we're about to explain. So, denary numbers, this is going to get a little bit mathematical, but a denary number is a number to the base of 10. And that means it uses 10 digits, it counts in groups of 10. And the column headings, you know these already. You have on the right hand side over here, we have units. We then have tens, hundreds and thousands. And for those of you that are mathematically inclined, you'll notice each of these columns is 10 times the previous one. In other words, these are powers of 10. So 10 to the power 0 over here on the right hand side, 10 to the 1, 10 to the power 2, so 10 times 10, 10 to the power 3, 10 times 10 times 10. And all number systems work along that same principle. Now, when you write a number down, for example, 2,457, that means 2 times 1,000, 4 times 100, 5 times 10, and 7 times 1. And if you take those and work out that calculation, you get 2,457. Now, binary, we've got a number system to the base of 2, and that means it counts in groups of 2. It uses 2 digits, 0 and 1. And the column headings, again, are multiples of 2. So we start off with a 1. You always start off with a 1. And then the next column is 2. The next column is 2 times 2. That's 4. Next column is 2 times 4, 8. 2 times 8, 16. 2 16 is 32. 2 32 is 64. And the next one will be a 128. So if you take a binary number like 1101, it means what we've got here is a 1 of these, 0 of them, 1 of them, and 1 of them. In other words, an 8, a 4, no 2s, and a 1. And of course, 8 plus 4 plus 1 equals, I'll wait a moment so you can work it out, it equals 13. So the number you're looking at right there, 1011, is 13. Now, is number 13, that's the first thing you've got to remember. That number there is not 1011, it's 13. It's just written a different way, in the same way that if you want to write down the number 13, you could write it in letters, you could write it in Roman numerals, you could write it as a tally count. These are just different ways of representing the same amount of stuff. And that's the thing you really want to kind of understand. A number is an amount of stuff. A number system is simply a way of representing that amount of stuff. And on the computer we use binary. Now, if we want to convert a number from base 10 into base 2, so denary, remember, is base 10. This thing here, this is base 10. Binary is base 2. What we need to do is we need to answer this question here. So it's a simple question. What combinations of column headings make up the number I want to want? So the column headings, 1, 2, 4, 8, 16, 32, 64, 128, they just double. We always start on the right-hand side. The number on the right-hand side, the digit on the right-hand side of any number is called the least significant digit, so it's the smallest. The digit on the left-hand side over here, this one here, the 128 in this case, this is the most significant digit. So if we take this number here, 37, well, 37, if you want to make 37 up, we need first of all, we need a 32, one of them. We then need a 4, one of them. And we need a 1, which is over here on the right-hand side, one of them. With numbers, of course, when you've got a gap, you put a 0 in it, like that, and we end up with the number 100101, which is this number here. So this value here in is 37 in binary. If I just erase all the ink there, and then we'll have another go, we'll have a look at this one here. If we want the number 23, well, we want a 16, and of course with that then means we've got we need a 4. And then we also need a 2 and a 1. And if you add those all up together, you get 23. We've got a gap here, so we put a 0 in there. And we end up with 10111. which is this value here. That's the number 23 in binary. So all you've got to do is just remember this simple question here. This thing here, what combinations of column headings make up the number that I want to represent? And if you can work that out, you can write the number down in binary. Now, if you want to convert from denary to binary, base 10 to base 2, you can also do there's another way of doing it, and this is, as it says here, to repeatedly divide the denary number by 2 until you reach 0, and look at the remainders, and if you read the remainders from bottom to top, that you'll have the number in base 2. So here's a little worked example for you. So first we're going to convert the number 26 into binary. We take 26 and divide it by 2, and that gives us 13 remainder 0. Now, because we've got 13 left over, so this 13 here, we're going to take that and divide that by 2. And when you take 13 divided by 2, you get 6 remainder 1. So then we take the 6, divide that by 2, and you're going to get 3 remainder 0. Take the 3, divide by 2, you're going to get 1 remainder 1. Take the 1, divide by 2, and you're going to get 0 remainder 1. So we now look at the remainders on the right hand side. We've got 1, 1, 0, 1, 0, and that shows us that 26 in binary is 1, 1, 0, 1, 0. So there's another way of doing it right there. Now, if we want to convert a number from binary to denary, so we can convert it in the other way now. We're going to take the binary number and then work out what does that mean in base 10 in denary, the normal number system we use. What we do is write down the column headings first of all, like this, and then we work out, and then we write the number underneath. And as you can see, what we've got here is we've got the number 1, 1, 0, 0, 1, 1. What is that in denary? Well, what we're going to do is we're going to do 32. We're going to add to that, we've got a 16, and then we've got to add to that a 2, and then we're going to add a 1 for this number digit on the right hand side over here. So 132, 116, 1, 2, and 1, 1. We're going to add all those up together, and you can work out what that means. So if you want to work out what that means, then I'll give you a moment to do that, and then we're going to move on, and I'll show you the answer. So what is the answer? Well, the answer is 32 plus 16 plus 2 plus 1 is 51. And the number you're looking at right here, so this thing here in binary, this is 51 in denary.